Hello guys, this will be another stream of me continuing working with Doom. Maybe I'll just show a few things I have completed and where I am, and I might try to add some performance testing code from an older project I never committed. But first I would maybe show you I could run this one. I will show you the feature I have implemented and I talked about. I have implemented this fake contrast thing just after fixing the gamma correction, because in the previous video I was talking about various things I'm trying to implement. And that's really, I have a screenshot here which is better. And it used to be that the colors of the walls, they're not the shading, how dark or how bright the wall is. It depends on the brightness of the floor ceiling of the sector. So where you open, I don't know, anything, and you have those sectors. This sector have a brightness value which goes from 255 to 0. And see here in the editor it goes 0, 16. It goes in step of 16. You could put okay, 241 or 247, but it will be really on the gradients is small. It's 16 gradients. So when I was making my first maps back in time, I was putting 10, 20, 30, but that was wrong because you could translate anyway to 16, 32. 10 and 20 might translate to 10 might translate to 0 and 20 to 16 possibly. So these sectors have lighting. This is a special word with, let's see, is it? Yeah, I did it. And when you lower the lighting, I'm pressing Control and mouse wheel. I'm lowering the lighting of the sector really, but every wall segment that is connected to that dark sector will take its darkness. So the line devs don't have their own separate lighting value in Doom. That means since all this area has the same lighting, forget about this depth shading, this diminishing light. This is a different thing. This is on top, but if you removed it, it would be same brightness all over this area. So all these walls would have the same light, but it seems a bit blunt. And I didn't notice, even if I knew how the sectors work, I didn't notice that Doom, the PC version of Doom, I don't know if some console, I don't know what Jaguar does, I don't know what, and yeah, the PC version would extra darken some sides, but only those sides that are exactly 90 degrees. So again, to go here, you can see it here. You have to run Doom. It could, these sides where it's horizontal and vertical, it would brighten and darken them. But this side that is diagonal, it's not going to alter it. And I think some sides And there are certain rules, like walls oriented parallel to the east-west axis, darker. I mean, west parallel. Okay, the verticals are darker. Probably the north would be towards there in this one. Doesn't matter. And it was used even in Wolfenstein. So why is this area darker than that? So besides the regular lighting, if you were to just get the sector lighting, the value of the sector lighting, and darken precisely the whole segment attached to that sector. Maybe this is broken in more sectors, but they all have the same lighting. Forget this smooth shading. This is a different thing. Is the initial sector value of the lighting. Then you get this very blunt, samey looking places. But now I have added a similar concept here, and it's very light. It's done per line segment. It's some extra code done per line segment, and not for each column individual. So you might have 50 lines or 100 wall segments at best. You don't have many elements. It's very few elements to alter performance. And actually, I tested it recently just to make sure. And you get this one. And this really makes it look better. The thing is, this is how the original 3DO was, and how. And I wonder the. Atari Jaguar. I wonder if the Jaguar, because this code was from the Jaguar. That's not the Jaguar, that the PC. I wonder if the 3DO code was taken for the Jaguar. I wonder if it could be the same, or they could have fixed that one. Let's see. Oh no, it's the same. Same darkness, same darkness, same darkness. Don't see, you see some darker sides because it's the depth shading on top. No, it's all samey. Yeah, because the 3DO was based on the Jaguar code. I wonder other, and so we have something that is better than the Jaguar. Okay, I'm joking. No, we still have to fix the frame rate, but a thing like that, it makes it so much better. Even in the distance, those walls, the sides, and so much better. And that might work in other places too. And I guess, yeah, I'm running. Look, we can see it. Oh, I'm running the old version. Am I running the old version? I want to show you that too. I can show you how it looked. I mean, you have seen the screenshots. Why am I running the old version? Because I didn't copy the new version. Because yeah, that was level 10. And I'll show you why I ran the old version. Okay, that was the old version. See how everything looks. Now, you see this turns brighter because this is the light diminishing rather than the cyan. Okay, this helps it a bit, but it seems all bland. And if I run the new version, I'm going to run it on the 4DO. The 4DO would copy the new version. It's the same. Oh, that's still the old version. Why is it the old version? Because I guess build it. 3D Doom board. Oh, I'm sorry. I'm running the wrong way. I'm running the yeah. Hope this doesn't fail because I was changing some code. I'm adding some code from this bench, which is an old version. Let's see it once. By the way, okay, this is a bit overclocked, so it's going to be faster, but whatever. It can be misleading if you see this video randomly. Move the time at some place and see, oh, is it optimized? No, it's much faster because sometimes I run the emulator overclock just for my own convenience, to be easier to debug. It's wide. Okay, whatever. So see, and that even works with the new stuff, with the gamma. Yeah, the new gamma. And also recently I made it work. Yes, some sides are darker, the horizontal, the vertical. Let's see, it says, okay, I guess the north goes there. So east and west is there. I mean the vertical and the horizontal. The east and west should be darker. No, actually, oh, no. I mean, it looks the same as the original. It doesn't matter. So there are specific rules that I did from the code by comparing the vertices of its wall segment, the complete wall segment. So a wall segment could be from here to here if it's not interrupted by a sector. Here, because it's interrupted in a sector, could be from here to here, here to here, and here to here. So it's not every tile. So it's few vertices overall. And have I done something else? Yeah, and I even changed some code. There are places. So if you do the polygon render, yeah, that's how you see it. Oh, you see even something flat. I haven't changed the code in the polygon. It's only in the Doom version. Also depth shading, the bright. Now if you put it bright, you still see the difference now compared to the polygon, which is bright, but now there is a thing. If you go far away, you might see some flashes. There's a reason for that. You see now, this is flashing on and off because I have there are some surfaces that are so thin that it's not worth it to do with the polygon render. You rather do it with the column, the far away also. Because there could be many tiny polygons where you would put the whole big texture on each cell far away, and that could harm the performance. And I did some heuristics. So the polygon render is not every. We could test that too. If I made it to render everything with a polygon, even the faraway surfaces, because you could have a lot of cell reads for the faraway textures that are very small and very few pixels. With the columns, it reads only the few columns needed. So if a surface is very thin and it reads 2 column from the two columns from the texture. Why read the entire texture when I do a cell polygon? And also far away. That's why it switches to the full. The close are the polygons and the others are the. You see this flash because this new feature is only implemented on the Doom. I will also add it to the polygon. It's not hard. I just have to go to various places. And it's also implemented. It's also added on the flat shaded. The flat shaded would look again like that. See, it was all the same because it was the same texture with the same flat shaded color, and there was no. It would get the lighting from the ground, which is the same. But this is also even the flat shader looks much better. It has this depth. It gives this color depth brighter and darker in the 90 degrees walls. Oh god. Here. Blank. See, everything goes the same with the flat. Now it's really like Atari version. Ooh, the Atari version has. Oh, I'm using the poly for that. Make it with Doom version. The flat shaded are much better with the Polygon version. Atari, it's a joke. It's like if it goes on the 8-bit Atari. And if it goes on the Amiga. But this preset uses the Polygon by default, because I think with the flat shaded the Polygon is faster. Is it so? Let's see. Okay, 30 frames, but put unlimited. 78. It is. Is the Doom version which uses still might use the columns. Anyway, this works with all of them. Those broken textures are broken even in the original, those little small. There's a code that didn't take account of very small 8x8 textures. I could correct it. So all of these modes using the default Doom will have this dark bright on the 90 degrees walls. The faster is a low res version with low res floor ceiling. I ran it overclocked, by the way, just so you know. Don't be confused. Anyway, so this makes even the flat shading. It gives it a different darkness at the vertical goal. And actually, this is with 90. I might have to play through other levels that has some 90 degrees and some in between. Because what it does, I have used the same logic in a place. And I didn't just copy the same code because a lot of variables are renamed and I had to find the right place where it makes sense to. It says if the y coordinate vertex 1 and vertex 2 of the line, they are the same, so it's a horizontal line on the map, then decrease the light number. But if it's the x coordinate, So for vertical lines, 90 degrees vertical lines, then increase. So anything in between is normal. This is darker, brighter, but if you had, I might have to make some level and see, or find some level that you can see it. So technically, if you do this vertical 45 degrees, whatever, any kind of degrees, even like that. So this would get, everything would get, make a sector. The sector would have lighting, if it has 128, then maybe this vertical line will be 112, this horizontal, or maybe opposite, 144. One of them would be 144, the other 112, and then in between the diagonals, whatever is the angle, will be 128. So you could possibly see a smooth transmission from darker, normal, brighter. So even for non-blocky levels that could improve. I just haven't run. I was testing this level. And it's the same. Those sides here with the armor, those sides are dark, so I think it's the same. Yeah, that's the one cool thing I have added, and maybe I should show you. I have this code bench. I also have some assembly. I was trying something. The only thing I was doing is I added and that's on some old. Those are old repositories. I added this flag. Maybe dash S. I don't know what dash FS is. If it's also needed. And this would compile, but the object files, will be something like that. And that's wrong. The linear will be it will never compile the actual thing if you put that. But that goes to force it. Normally I should make a better make file, but it doesn't matter. To force it to spit out the assembly. And you have also the source code. You see the source code and the generated assembly. That's really useful if I ever going to investigate again the code. I'm curious about something. Probably not, but okay. Yeah, mul, sure, but there was a mul. Yeah, that doesn't exist. That's one ticket I have that I was thinking about. You don't have div. The div is a call. It's a branch to a division. This is from the compiler, probably. The ARM doesn't have divisions. Anyway, let's go back. So I found this one. This one, if you build it, let's run it on Phoenix so that we are fair with so that we don't overclock and we account for cell cycles just to do the access. But what that was, oh, it doesn't show. This is the previous version with an older menu. And it has the gimmicks. I will show you the gimmicks. These are features I removed, at least most of them. It was at that version that I was doing some wild stuff that are not necessary for playing the game, but I kept them inside. And I will show you this special version that I have to update the current repository with those bends. I will show you something else. Okay, maybe. Maybe. Oh, I had the scalars already. This is the 02B version, not the 02C. I already had some cool stuff. Oh yeah. So those are irrelevant. Those are gimmicks. So this was the okay. This was the first gimmick. Wireframe Doom. The scale doesn't. Oh, the scale does matter. It even does it on the wireframe. So this was wireframe Doom. I render everything with wireframe. You even see there are some surfaces there. I had a little idea for optimization, but maybe it's not working because there are few. That okay. This used to be the wall behind, but if you go here, the wall is hidden. And here everything is hidden. But because the above is open, even if you go here, you put the wall frame here, everything is, you can see everything. But a lot of these things are hidden. So I was thinking that I could do an extra optimization where I will skip the rendering of certain wall segments if I can somehow find that they are occluded. But that might not be easy, and you might need more CPU to detect that than actually rendering. Maybe not. Maybe I can check the higher and lower of the nearby. How do we render the 3D Doom was rendered back to front, I think. But this is opposite actually. The PC Doom is rendered front to back, but still manages to hide to do some extra checks to not render something that is hidden. 3D Doom is rendered back to front, but I think. Oh yeah, you have seen. I think it doesn't render the full wall. I need to check that. I think that it renders part of the wall. Maybe it. Okay, I know how to check that one. So there are these things that I need to investigate. But when they are completely occluded, those segments behind when they are occluded, even here, I should be able. It might not be easy. If you see them diagonal, you have to do a lot of checks for occlusions. If it's straight, you can easily check up and down against other. Maybe it's not so. This wireframe helps me to see if I can do some extra occlusion. You see when I close the door, the sprites, now this is shut close. By the time it opens, things appear and then the sprites appear. So there is some occlusion happening, but if a wall is not entirely closed, nope. This is really nice mode. I don't have this mode in in the latest version, but I have found some code. It seems like I kept this code. I just disabled the option, and I have some defines to also disable the code, to not even compile the code, to not add it to the size of the executable, but only enable it if I want to check things. It's pretty interesting to see the wireframe. Now the next crazy shit. This is the craziest thing. Oh, this is slow, of course, now. This is running Doom on a cube. Okay, this is the most impressive thing for me. This is using my 3D engine to rotate a 3D cube, and the quads are cells, okay? Regular cell text. But the cell texture is not any texture. The cell texture is feedback texture, because the 3DO has feedback texture. Effect. So I after I render the whole thing, I grab the frame buffer, and possibly I grab only this for a frame. I don't grab the extra. I must have done it nicely, because else you could also see that those parts in the bar. I grab it and I use it as a texture. And this is running on the cell. This cube is reading the frame buffer and using it as a texture. Is running on the cell. This is very impressive. And then there is this. Okay, the distorts. This is something I have used. This is a feature I have used for the special levels I made, where I make a certain sector, extra sector options to make it distort when the player is in. And this is the early version when I was. This is the feedback effect of the. You can render the whole thing in a back buffer and then read back the back buffer. I split it in several quads and I move the vertices of the quads. So this is a second pass where I can do various feedback effects. And that's the cool one. I never used this one. This is cool actually. Get the frame buffer and blend it with the previous frame buffer. This is blended. This is blending effect. You could do that. You grab some item and you're. This is true motion blending, motion blur thing, sort of. Isn't that cool? But okay, I haven't shown you the reason I recompiled this old version. Remove that. The reason I recompile it is because I wanted to profile and I added a whole inline profiler, my own profiler for certain functions. And by the time I do that, you get that. And I have selected certain functions. It's very slow now, of course. So that I can go at certain places and I guess if you overflow, is it it's not it's not the extra cells. Let's make it a bit easier, but maybe it will affect a bit maybe not because they are analogous. It's not affecting. It just make things easier because now I can go outside and see. Okay, when I look, what kind of percentage? 94% render player review. Something outside of it is taking 6%. Second one, draw planes, draw this plane, draw walls. Here a lot of time is taken in draw planes and not enough on draw walls, so I can go. I can't even see here. I have to do it. Let's reduce the floor rendering. Make it flat. Draw planes 24. Yeah, we reduce. Yeah, okay, yeah. So at this view, the plane, the floor, for example, is taking more than the lines. Although there are enough lines. How do you know it's the software rendering? Especially here. Now, if you stick to a wall and there are no draw planes, there is no floor tiling to draw in this view, so I could check various things about performance. Draw walls 13%, star set globe. Some of them are See, the percentages don't add. They don't add 100%. I have selected certain BSP takes 1%. BSP didn't take as much as I thought. Okay, it takes like 4%. You think the BSP is really fast. Maybe in some places it takes more, in certain angles. And I think if I look there, there are cases where I saw it at the best, but you see which parts you have to optimize, but it's both the wall rendering, but not the wall rendering and the floor rendering, ceiling rendering. The floor ceiling is the vis planes, the planes, the segments, draw wall segment loop segments is the wall segments, and it's all over the place. And some of this function, for example, the render player view might call a lot of this that call a lot of this. So I don't have the tree of the functions here. Some of this maybe some of these functions encapsulate other call other functions, so they are not separate. But you can kinda see where things are taken. Now I want to kill those because recently I realized something else and I made a ticket. I realized something that maybe I will put where is the stats frame rate. Now I don't have the option to remove that. If I do this toggle, it starts it again. I should put it. This was a hack I did then. So 36. I'm close to this door, but not below. Close to this arch. When I'm in, it's 41. Okay, maybe because I'm here and I look forward and I don't look on these sides. And it's such a big jump. When I'm exactly here, to when I'm barely here, barely outside behind this line. So here it's 60. Ah, yeah, I have the map here. So something happens here. You might say you are in this sector and maybe the BSP works and but if you are in this sector it works forward and not from the back. Maybe it's that. And also obviously if you look at the map everything goes to zero. Because nothing is rendered, you are just looking at the map. Other functions are running, obviously. And you could maybe even, you know, make various conclusions. Like, if I change the scale, are things maybe things are analogous. Let's see. 60, 43, that FPS counter. I needed a bit. 37. Draw goals 5%. Draw goals, but everything raises. So what is something is I need to see that because I need to see what is the rest percentage or because now this is those functions are not separate. Some functions call other functions. So I should have the tree, or I should display only few functions that are relevant, and I will show you. Actually, I have made some yesterday some trees. I'm now in the investigation mode for the performance. I might just throw a lot of days in that, and maybe we can crack it. Maybe we can even without because one goal was to replace the floor and ceiling with polygons, but maybe that's a separate. I have to see if even in this engine I can get a little bit more performance, because sometimes you have to throw more. You might have written code and then you go back to old code, or code other people wrote, and you look at it and it says I can't do anything. It says performance it can be, but you give a second look later and later, and then new ideas might pop up. Something that yesterday you thought it cannot be any faster. It's as fast as it goes. I see at the code and I can't think anything. A different day, a different week, you might look at it and get that spark, like, oh. But of course, Doom is much more complicated than all my demo scene effects, which are individual brute force loops where it's easy to figure out faster ways. So it will be more interesting. I did very small improvements. So I want to see, okay. Now the frame counter hides, but I need the frame counter because BSP is at 1%. What change is there? I need the frame counter because I could display it in another place. I want to go slowly. Is it still in? It suddenly increases. Okay. Can I do that? Less time spent on render player view, whatever. 70. Draw planes, draw this plane. Oh, those are taken. Okay, those could be the same. This could call draw this plane, call draw planes. Map plane any for. Oh, okay, maybe I know. I don't know. 19 for. The other thing is the mistake I'm doing. These are percentages from the complete. I should have another display with, I don't know, milliseconds, because these ones are analogous and you cannot tell. It's between each other. It's like you can see at which views the whole rendering takes more time than the plane. And when you go there, there is less lines to render for the planes. Let's draw. Map plane is the final. And draw planes and draw these planes. Let's have dropped. I cannot see the sudden increase. Oh, but okay. The whole render player view from 90 to 85, and I don't see it on the BSP. So what is it? It could be something different. Interesting. Because some things drop, but why? Seg commands, okay. On the right side I have the screenshot. Let's remove that so that we can see. Seg commands drop because when you go close to the wall, there are less wall segments, less columns. Seg commands are for the columns. And I think I know. There is some code. Here is a wall that is top to bottom. This wall is full. And here is a wall that has a middle section, upper and lower. Those are running through different code. And I think I noticed that and it makes sense. So in here, when there is the arts, it has to do the arts, and that's extra sets of columns, and maybe it does some extra checks too. And when you go here, it doesn't have to do the arts there. It has to do this wall, this wall, and this wall. But I've noticed that there could be some bottleneck on the when you have upper, lower, and middle texture. When the wall is split so that you have a hole, it's not a solid wall with no upper lower. I have explained once. Things are much even here I mean you might say there are more wall segments with more columns to do. More seg commands, less seg. Okay, because yeah, it's just a wall, it's more wall segment. Yeah, it goes by 3 because it's separate columns. This one separate above. And that's how it. So it could be nothing. I made some kind of note that hey, why is this happening there? Why is the sudden? And it could be something I could see that things like Windows, not because of far away, because it has a lower texture and upper. So suddenly from a single one, it has to run some code that does 3 times, of course, the work it needs to do. But maybe there is some extra check there or something extra. And if you have many segments, it's an overkill. But also if you have many viz planes, it's an overkill. It makes sense. So I don't know what to say. So I could show you. So what's the plan? I have ported some of the code. This is the new latest private. Now the public is the one I'm releasing, and I will move more of the changes from here to here. And recently, I mean yesterday, I was doing work. A few days before, the fake contrast, the VDL gamma. I added some extra bench stuff. However, I have a define profile on, so that if I don't define this, these parts are not going to be compiled for the file. It's only a debugging mode for me. And I haven't used them yet, because here in this old version, this was based on the old version. No, not this one. Boop, boop, boop. These are some extra function. Clear bench period, start bench period, start profiling. I had to add this extra stuff. This is I have shown you that, by the way, before. These are some old video I made where I show, yeah, I'm doing this profiler to figure out what's going on with the speed. And I think, no. So here at the rendering, and this is old code, by the way. I say start bench periods. Yeah, I put a number manually. Huh. I could have some increasing index or something. Possibly. Unless I want to... Okay, there might be a reason though. If I have an outer function, I'm going to say end bench period with this index that I know. He could use the name, but... So you have render BSB. That is doing other stuff. So all this code that is doing various calls that are related to the rendering, much deeper if you go deeper. I was benchmarking the this plane find plane, because there was some talk that the this plane, the way it was searching for the common this planes, it was doing a very bad search, but I realized with so few this planes, it doesn't seem to matter. It might matter for levels with a lot of these planes on PC. And I remember there was one day I did a hack. I got some source code from Boom, or I understood how they made a faster hash map based this plane searching, and I think I implemented it well from there, and I didn't notice any improvement, unfortunately. I thought, but wait, I want to run it again, so. I don't want to run it again. This fine plane, did it took a big percentage or small percentage? We will see the percentages. Let's see it. Because I didn't notice it. Find plane, 2%. Yeah, it ends up... There was talk about Boom having a more optimized version, but that's for very high detailed PC maps that were released later with that exceed this plane number, because it's doing a very simple search between the this plane. Now I know if I go here, this view is heavy on these planes, and fine plane is still 2%. What if I make it so simple that fine plane goes to 9%, but it's much slower than the others. It slows down here for some reason. or go to, I don't know why the Phoenix is slowing down. Maybe it's too much for Phoenix. So fine playing was never any serious issues in performance, or the BSP resetting that happens in the beginning. I had the short sprite. I have seen this short all sprites, but it's, you would have to try with many sprites. I don't want him to bother. So even with those modes, draw planes, draw this plane, sec commands, start seg loop, map plane any. You can see where most of the performance goes. Fine plane was never a thing, and of course I tried at some point, and maybe I didn't do it right, but it wouldn't even give the performance. Anyway, you see, we are using this start bench period. Now if you go on my current project, search for start bench period, you will find it only on the bench and over here, because I still haven't implemented. Let's see. Where is it? Because I started moving code from this old to the new project, and it will be interesting to see if anything changes in the performance too. And I might have to change things in this system. I'm doing a clear bench periods, maybe at startup. Start profiling. But also I have an update bench. It updates the duration is 1 second. So it starts accumulating how much time the code spends in different areas. And I guess after that it clears, which might set everything to 0, the time sum. And star profiling will clear. I use this get u time, which I think this is from 3DO. I thought I didn't. This is a more high resolution timer, from what I remember. For my frame rate counter, I used the regular resolution. This was a higher resolution that I thought I couldn't make work before, but I did make it work for the profiler, which is good. We need that. And I end up taking percentages from the compared to the total. I could have the U time to see differences rather than to see if I do something in a specific function, how does it change overall. And you have to select specific views. Okay. Because I can run, there is no point to run a time demo. And I have to implement this. God knows how. And I prefer to select certain player views, especially those that are slow. Interesting player views that give specific result and compare results and get some conclusions. So the start bench period, this is the new the latest code I'm working on, and I have moved some of this code. Oh, I'm not doing that yet. I'm not using it. Huh. I will need to call that. Ah, I didn't do the update bench. I thought that this is a update and this is every frame, and I am updating the benchmark. I accumulate some of the results from the different functions, and I will also draw things on that, draw a rect and so on, and maybe I'll flash the CCBs at the end. This is the doom function that just draws the list of CCBs. It does the draw cell, the linked list of the cell CCBs, and I even do some sort based on the performance. It was just a hack, and maybe that's why it's also short bench results based on the time percentage, so that I see from higher to lower. I don't know if you always want to do that. You might look at specific function and then you change something and the bar goes lower in the list and you lose it from your eyes. I mean, that's cool too. So I did the whole thing, but this is where I haven't used that yet because I never call start profiling. No, I think I do. I think I changed some. Oh no, I don't know why it doesn't show it here. It was in no main. Did I put a space? Maybe I put a space by mistake. I put the same thing on the same toggle on the menu to enable the profiling. I should make it enable and disable it really. Shouldn't be hard. So now you have to go here and enable this profile on to enable everything. It will go to run. I will also show you something else. Run Phoenix because it's more cell accurate, but then again you need to check the CPU. I could run 40O. We don't. The speed doesn't change, and this is even overclocked now. So. Now I have this old mode. Ah no, now it's a word. Is it a word? I think. So this is a hack of the original E1M1 to make me teleport at specific places, and I also remove the monsters. So I did this back in time and I still use it. So here oh, where is the option? I think I had the option. Did I not copy it? Anyway, the map, I will figure that out. This is overclocked by the way, so well, I'll put it underclocked. I'll put it at its normal speed to see. These views are still very low, unfortunately. But this is full screen pixel high column. This is not like 2 by 1. or flat shaded or whatever. And even that can be slow. What I did is, if you move, you teleport there. You leave the controls. I would write down those numbers. I made it so that these are special views. This is the slowest view, and I have chosen to check performance. This is a nice open view. That is a bit better. That's it. I like this view because it has the zigzag sectors that take a lot. And I don't know why. Also, here I noted the numbers. This extra number is when I use the Polygon engine. In most cases, if I have an added, it's the same. In one case, it does a bit better. Here it's a bit slower with the Polygon engine. Here it's a bit faster, like 0.1 FPS. I have the okay. I defined profile on. It's the same. I haven't make my make file to. I was looking how to do it and I had trouble and I hate make files. I don't know. I just have to remember the. I'm going to run this one now. Now this is overclocked. Okay, again. Don't be scared. And it doesn't matter if I test it overclocked because I can test the CPU different. I could hack something and get a certain performance and compare with the previous numbers. Even if it's overclocked, it will give you me at there is an improvement compared on the previous one. Yeah, now I have an extra profile, but it doesn't do anything because I have it added. And maybe we could do that. It's a bit tedious. Again, how does it work? How did I do it? All you have to call is start bench period. You give it a name, but you have to put an index. You have to remember the index. I could do it better, of course. Maybe you would have to say end bench period with a string to set the string. So start bench period, number and name. And now look what other thing I was doing yesterday. I was looking at all the relevant code. Is it this one? And I was taking notes the whole Doom pipeline. There are so many different functions in different places called. There is a history why those files are called. This is from the original 3D Doom. Phase 8, Phase 7, Phase 6. And the story goes that on the Jaguar, because this code comes from the Jaguar, the whole rendering pipeline is split in several parts. Because they would load it in on the RISC processors. I think there is the GPU processor or the object processor, graphics processor unit, which is one of the 232-bit RISC processor. It's really, you run a lot of CPU logic there for your rendering or for whatever you want. And there's the DSP which works different, but on the DSP they might have added things that don't have to do with the rendering, but they have to do with the enemy, the gameplay AI. They say the AI. Maybe the gameplay, the movements, the collisions, the bullet hit scan of the bullets and all that stuff. That was the reason they said we couldn't use the DSP for music. Someone else is doing it on the community because we use it to optimize that part, so there wasn't time for the music. There was actual code of the music on the Jaguar anyway, but it wasn't used, and someone enabled and fixed some stuff, and it works. So those phase 1, 2, 3, 8, and some of them it goes. If you look at the source code, phase 1, 2, 7, 8. Now, is this the original? I call it 0 because this is the commercial. The commercial had phase 1, 2, 6, 7, 8. You don't see 3, 4, 5. I don't know. Maybe 3, 4, 5 had to do with the sprite, the gameplay. Not the sprite rendering, but the gameplay movement, which is offloaded in other places. And it used to have 6. Now, 6 goes 12. Now these are big. I have added more. Now, phase 6 is smaller. It's 7K. And it calls function. This is my work. Those are. I wanted to split the code because I added a lot of extra stuff for the extra low res mode, flat shaded. The PL is the polygon mode, and I reorganized the code. But you see, there is way more. I reorganized the code so that it's easier to work. I don't have everything in phase 6 because it started becoming big. And I kind of have an idea what each of them represent. And it's interesting because this phase C files, they don't exist on the PC Doom. If you look at the Doom PC code, some of the stuff are exist in other main rendering, maybe in air main, render main, or some other places. Maybe there are some other files. But these are historically these are from Jaguar because Jaguar had that was it. Jaguar had to offload this code on the RISC processors, but there is a limit. I think the code has to be as big as 2 kilobytes, so there is a limitation of how big the programs you offload on the RISC processors are. It has a small RAM. Now you could run bigger code from the main memory on Jaguar. The RISC processors could run their code from memory, but this tends to be much slower. So it's better to offload the cache, and the whole rendering pipeline would never fit in the RISC processor smaller memory. So they split it into pieces. That's what they did. That's why on the Jaguar, this is where those phases come. This is the history. They split the code into pieces. And now, if you get the Jaguar source code, because the Jaguar source code is released, I think I tried to look it, and those phases were pure assembly. And my guess is there is no way Becky in 2 weeks, she had 2 weeks or 3 weeks, or she rewrote the assembly from the Jaguar RISC processor, which is an entirely different processor that you have to know, into C code. So there is possible that there is an earlier version of Jaguar Doom where these parts were written in C that Carmack gave to Becky. That's my guess. But the one we get for the Jaguar, the final released source code, is, I think all of these are in pure assembly, because I think I was looking at it. From what I remember, I was looking, and I might be wrong. I have to look at it again. I'm curious. You will see some files are different. Are same. AM underscore main, D main, O main, B. Some of them you will find similar. And so you will not find all of the files. R main, the rendering main. That's in C. If dev Jaguar doing some weird stuff. And I might find similarities, but airface gas. This is the assembly. You see, it's all of them. 1, 2, 3, 4, 5, 6, 7. There is a 9. On Jaguar, those face, but those are pure assembly. In the whatever assembly language those disk processor here. So I don't think Becky might have gotten that one, but might have gotten also some original C code. So they might have written parts in C and then rewritten in assembly for speed for the RISC processor. So, but the final Jaguar code we have all of this. This is the whole rendering pipeline. All of it. There is a 9. What is the 9? GPU emule. Code starts. I think this looks like some unrolled code. Could it be the whole column renderer or something? There are unrolls of the rendering to speed up. Which the whole column, we don't do it. We do it with a cell. We do it with vertical column cells. Same extend. There are a lot of. Yeah, could be. BSP. The R1 is the BSP also on the store wall range. It traverses the BSP and adds the walls. The R2 wall prepare. There are some early stuff that happen per wall segment before you traverse every wall segment individually. Then you go to see. So I made an I just go back. I'm just curious, but on the 3DO I made with some horrible ASCII art. I put some functions that are relevant, so that I can look at this whole thing and have a global idea that the whole process to render. So everything starts from R main. That's just a small function that calls a lot of functions. This is phase 1, this is phase 6, this is phase 8. Now phase 6 calls something that calls for the sprites. In the phase 8 are the sprites. If you go on phase 8, there is still a GPU emule all over the place. Multiplying the GPU. Yeah, draw this sprite. Yeah, exactly. Interesting. This is a pre-step per wall segment to calculate scale constant for the wall. It prepares things for. These are cheap. The BSP and this is cheap. This traverses the binary space partition created by the sectors and the lines. So this happens for very few loops. If you see it, a lot of things are done, but overall the performance as you've seen is like 3% or something. compared analogically speaking, compared to the other. Because if you go at a very close, this will go up, but because it's analogous, the percentage is analogous to the total. And this one, I think I've seen that too, is preparing things for the whole segments. But it's preparing, does very little things. It's only those phase 6. Phase 6 now will call things from phase 6.1 to draw planes. That's wrong. Oh, I must have missed some tabs here. Yeah, okay, I see. Start seg loop, where you see seg loop is on the whole segments, but it will go split the whole segments into columns, so you can have one big whole, but it will loop 200 times depending on the size of the, and do a lot of stuff per column. So these are cheap because they do stuff per sectors, and on the BSP tree, which is very fast, and per individual whole prepare some values. But phase 6 is where the planes are the floor and ceiling, so it goes on phase 7. The sprites are still cheap. Most in some cases there is a bit of performance if you have a lot of sprites. So this is the core where the performance is. It's phase 6 and 7 I could focus. And it's funny, you see, the viz planes. This is drawn with the viz plane, but the viz planes are already prepared. The find plane thing is 6.1. Now the walls for every wall segment through every wall column, these are the heavy loop. There are 2 passes. This is how it happened before. I just separated them. Code from this goes in phase 6 already. I just separated them to group them and be able to see. And this has to do with preparing both for drawing the walls and drawing the planes. Through the wall columns, it finds the viz planes, and it finds the horizontal edges. It finds the gaps the wall columns leave in between for filling the floors. So it does preparing, but it does a lot of preparing stuff per column, per pixel horizontally, let's say, or per column horizontally for every segment. And this was supposed to be heavy, but it's not in our case. But this is what will help phase 7, where we have prepared the viz planes and now they will draw. And it does some stuff here too, but the heaviest, the map plane will finally call the assembly function span draw func. The span draw func, it's really draw a span, but now I have added, this is the only assembly I have added the low detail draw span, following the same logic with loop unrolling. There is no repeat. I think filler. There is a macro. Where is the macro? Yeah, this is, it's very, I know what it does with the texture coordinates and whatnot. This is the UV texture coordinate does, fixed point texture coordinate results. And then it ends and all the pixel results, and it must do the end to Somewhere here must be an end. Maybe that's the end, and the OR is the ORing of the pin. It could be that, or it could be something else. I don't remember. Because you might have to end the texture coordinates for the repeated tile pattern on the floor. But anyway, so this might be repeated several times. You don't see there, but the macro will expand this in the final code. And macro filler. The code is here. This part will be repeated here, and an address will calculate it. That will be added to the PC, the program counter, so it does a jump inside depending on the length of the scan line. So it has unrolled everything to increase speed. It's pretty tight. Although I had something in mind to improve it, but it's one of the tickets. I might have to drop precision, and it might be hard to figure out how to make it to not break it. But even if you improve it, you see, even if you don't call this one, for example, the flat shaded, no texture, will never call this function. So, but even if you enable this, you get some speed performance increase, but in a certain view with a lot of whole segment, it still goes very low. Even this reduction, even this remove the floor and ceiling, that has to be done with software rendering. Unless I figure out some Polygon based method, which will be a pain without texture coordinates. Yeah, so this is the final assembly rendering anyway, and it's only a 6._2 where I have the different versions. Draw seg texture, texture unshaded without the light diminishing, flat with the light diminishing without the light diminishing. And all of this will call draw seg. I might have organized things and make a common function to improve visibility. Now, I was a bit skeptical. Do I degrade performance? But so far, I did some benchmarks between the later version and it doesn't degrade. In some cases, it improves because of some other. It might be worth to recheck again. I might have improved the function and degraded in other places. But from what I have checked, the place where this is at, it's not done. It's done per whole segment. Maybe here is done. It breaks it into columns, and I have to see it. Now these are the final functions that will actually create the CCB structure found on the cell to render with cell columns. And it might call the flash CCB array. These are linked list cells for maximum draw cell performance. If it is a maximum, as you add more whole columns, it will flash, it will call the draw cells. But if it doesn't, when it finishes, if the number is small, somewhere in phase 6C will finalize the rendering and call it there. And also the viz planes will render horizontal cells linked together, and the extra thing is it will do the software rendering inside the texture of the cell. But the cell is still used to darken to say it, so that it doesn't have to do also the darkening of the pixel on the CPU. It's done on the cell, so it was still, even if it goes slow, it was still pretty cool system. I mean, a lot of these things were like the original commercial. Even the original was using the cell as much as it could at the time, and the limited deadline. So in the phase 6 one, it prepares rendering the goals for 6 underscore 2, but it might just render the sky early on, and it prepares some information for how the goals might be clipping the sprites for much later. So much later, some extra information, but so it's like a two-pass solution for the wall columns. One to prepare extra information, then also the viz planes for the floor rendering. So that also takes time. And I have then the Polygon version, different version, flat shaded polygon for the wall textures. I have to subdivide further I cannot render one big quad for a wall, but on the flat shaded I can do that because it is not gonna distort the texture, and also the texture is tiling, so you had to. So the phase 8 drove is the visible sprites. I think it's drawn back to front. In the very beginning, through the BSP traversal, it would also find the sprites and sort the sprites to render them back to front. But as they render back to front, they are also clipped. You might have a sprite that is partially hidden by a wall, by an elevated floor, in stairs, and this is what in 6 underscore 1 this segment wall segment loops with the visuals would also mark sprite clips for the later rendering. But the sprites also has to be rendered back to front because sprites are transparent and you might have to parse transparent pixel of the sprite might have to look, what is behind might have not to be erased. So it goes the best. I think we had once a discussion with Becky that maybe you could, of course, if you avoid the viz plane thing and some of this, even those calculations of the sprite clips, maybe the whole thing. The idea is this could be avoided if you make a polygon solution for the floor and ceiling somehow. But you still had to sort the sprites to know if they're in front or behind, if they are partially hidden by walls, so that they don't pop up through walls. And I think she told me there was a YouTube comment where I once discussed, like, that was an idea that you would mix the sorting of the sprite with the sorting of the wall segments, and the wall segments they start to be populated on the BSP traversal. You go through the subsectors, the lines of the subsector, and even if a line is facing away, its back face called, it's not added on the list, only the front face, the ones that will be visible are added, and you could mix maybe the sorting of the sprite with the overall data. Maybe you might need a different structure, I don't know, so that you render everything back to front and then render. It could be wise to first render the floors and ceilings, not with these planes, but with the 3D transform polygons, and then render back to front walls and sprites united. And that is the idea. If I want to rewrite, I will have two goals. Now the time is very short for the 0.3 version that I plan to Doom release date. My thought was maybe, and that was just a deadline I put to myself to put me back to working this project. I could go for 10 December 1993 for the version 0.3. And I don't think I have time to implement the whole Polygon solution for the floor and ceiling and the sorting of the sprite. So the other thought is, if I can go back with a better view and try to optimize what is already there, if I can get a bit more. And I will also be adding the new features, like the fake contrast, the gamma correction, which are nice. I don't know, fixing things here and there. You have seen my track thing. Yeah, there are some things that could be easily, no, but not high priority already. I have put this optimize in everything related. I have changed the time so I can do the summer, and I know that these are things I could. I think we will get a nope with this one. Because the 3DO has this one. I was always confused with, when I look at ARM, product family, architecture, processor, ARM6, ARMv3, ARM60. I forget if they ask me, oh, what ARM processor does the 3DO has? If I say ARM3, I guess we go with this one because I see Cortex and oh no, ARMv7. There is also Cortex here. They are the strong arms that were found on the later Acorn Archimedes. There are other X-scale. The ones on the mobile phones. But anyway, I know this is the one that has 12.5 megahertz. I don't know. It says 10 MIPS at 12 megahertz. I don't know if this is true. I think it might be more. I was looking unless the 3DO chipset, the overall chipset is making it slower than it should be. And I was looking, there was a discussion of some instruction, the simpler instruction taking 2 cycles, and some memory instruction taking 5 cycles, 2 to 5. So how can it be close to? It could be 6 or it could be less. I don't know, 3 to 5 MIPS. I mean, those numbers never make sense, the MIPS stuff. So the 3DO has ARM60, and there is a very important instruction, long multiply, where you multiply 32 by 32 register and you get a 64-bit result. Now the 64-bit result, this is something also the PCs, the x86, this is the 286, 386 and so on have. And while the ARM is a 32-bit processor here, they have a long multiply that the result doesn't overflow, but it gives you back two registers, the result in two registers, low 32 bits and high 32 bits. So you get a high 64 bit. Now, when we do fixed point arithmetic, we might say a multiplied by me, and then we shift back the result. Maybe we shift by 16, but the thing is, a and b is 32-bit numbers. But if a and b is big, if it's 2 in the power of 20 and 2 in the power of 20, whatever, in the power of 16, whatever. I just do it with power. You will get 2 in the power of 20 plus 16, 36. So this is over minus 1. So this has overflowed, and you are going to get the wrong results. And the ARM processor has a mul, but I found there is an S mul. Where is my... And see, you give multiply n with m, and it returns a 64-bit result in two other registers. And if it doesn't overflow, the high would be 0, the high register. But if it overflows, you could do... Okay, you can... Because the fixed point, you're still in 32-bit, but you do that and you shift back by some value. So this will initially overflow, but then you shift it back and you get a value that inside the 32-bit range. And if you write C code and it uses a regular mul, okay, the problem is that here we are there, ARM v3. ARM v3 first to support 32-bit memory address previously, but ARM v3m first added long multiply instruction. Damn, it's very possible that the 3DO has ARM v3. It's very possible that we were right on the line that we are missing this very important thing. And why is it important? Because I have this one. Becky is using these functions. I mean, okay, we can't escape the division, but there are very few. I found a lot of them, but maybe they are in places that are not affecting performance much. There was only one place that would affect performance. See, these are fixed point functions that are in the burger lib int math, isn't it? Which will, if it does extra checks, it says, okay, if there is no overflow, if you detect, it says 16-bit fixed point. This is not, this is the, yeah, this is the fixed point representation. It's not 16-bit, it's, yeah, that's right, 16.16 is 32 bits in total. Uh, it will do some mul. It doesn't check to do it faster. Here it calls a mul 30 to 16. Mul. If one number is bigger, input 1 is 32 bits, input 2 is 16 bits. So it tries to emulate this 30 to 64 bit mul, very large numbers that would overflow. And if it realizes that we have to do the full thing, it does way more, it does 4 muls. Because it has to emulate the full 64-bit result. And then might shift back to the original fixed point representation. So because most probably we don't have this S-mul on the ARM processor, and we were right on the line. It wasn't like a feature that was 2 generations later. It was the generation. The 3DO could have that extra chip that would do it correctly. We have to emulate that. We have to call those at various places. Now, a lot of these places are really they are not insignificant places. Apply IDKFA. The map. AM control is the map, the auto map. Enemy, something with the gameplay. Skull attack, the movement of the lost soul, probably. But I see some of them are, you have a lot on the BSP calculations, but you have seen the BSP was taking 3% at some player views. It wasn't the one where everything concentrated. And phase 2 is for the whole segment. This are there could be if there could be a performance improvement, but maybe now phase 6 aren't these the heavy ones? I need to see that, but this happens per whole segment. It doesn't happen. This is a code I copied, but maybe I can replace it because I copied it from here. This is the heavy part. And see here, maybe put it here. I have commented it out. This part used to use fixmul. Let's see. And I keep the code in case there is a very big hole. In some level, there might be some hole that this breaks. It overflows. And I have found a way, there are a lot of parentheses here, to do a temporary shift down in one of the... I do a regular multiplication. This will be compiled as a regular multiplication. Segl distance with this one. I do it after. I do a pre-shift. But I do it after. It used to shift right by frac bits, but maybe it's what happens later. I do a pre-shift. So that's what I added. I did a hack. I need... But the multiply is inside. Why doesn't that overflow? And later I subtract that from this segl offset. And shift it again by the frac bits. the thing is, I find a way with a preshift of the values to avoid certain overflow, but that doesn't look right now because the multiply happens inside. IMFX mul, find tangent with the segel distance. But okay, do I do something extra? Find tangent. This shift happened before. Is this the same? This and this is the same. I do normal multiplication, and the result I will shift it right. Not by frac bits, by frac bits minus this plane distance per shift. Visual distance per shift. And then I will subtract it from segel offset. And then I will do this frac bits outside. But because you know the idea was that if I had this and this overflowed before you do the shift, this overflow, the idea would be to do, okay, shift it a bit down so that this multiply is still not overflowing. The numbers are smaller, but you lost a bit of precision, and do the less of the shift rest. That was what I was trying to do. And now I do see that I do the multiply inside anyway, the regular multiply, and I do the extra shift outside, and it's frac bit minus. Oh, okay. Maybe. Okay. I know. I see. Early. It's 8. Early preshift of the store visual distance to allow me to replace IM fix mul with regular mul in the rendering critical parts. Yeah, okay. This is a bit of a hack. We do a bit extra. I know. You don't see it here. In phase 6, this is the preparation. This goal seg pointer distance, I shifted right by it, so I did reduce the precision. Which I don't know if it didn't seem to have implications. So that, and this goes the goal seg pointer distance. Now you don't see goal seg pointer because we are looped through it. A segel distance is the goal seg pointer. So this one, I have pre-shifted it outside. So this one is not what it used to be. This one is shift right by 8. But this one is not. This one is still hide. So I multiply, this was pre-shifted and it was in the pre-calculated before to not have to do it inside. And this second shift is for the other one that isn't pre-shifted, for the other 8 part. So I had to do this thing. And that was an idea I had one day and it paid. It really did pay. I don't know if I found. That was the idea because in this bench there was different. This could be a 7 or an 8 and it went to 9.3. This could be. I was benchmarking and I got some 10% or something. Because this loop is critical. This loop is every whole column of a whole segment. So you can have a single wall from left to right could have 300 columns or something, 288 in the biggest window size. if you have a lot of stairs, a lot of windows, the total columns, this could be repeating for 2000 columns in the worst cases. So this is not per wall segment, it's per whole column for each wall segment. These are a lot of, this is the critical part. So I avoided doing the fixed mul and it did pay. Even if I had to do some extra bit shifting dancing here and in the other place when I prepare. And now, wouldn't that create horrible precision in the wall rendering? It seemed okay. It seemed okay. It was still okay for this one. And this is finding the texture coordinate on the column. Which of the bitmap column to draw for each column, which pointer offset or something. And if I didn't do this trick and I just did the multiplication, and also in phase 6 in the preparation I didn't do the other thing, I would get, with the regular multiplication, things would overflow and I would get some very, very wrong texture columns. So it was quite a hack to avoid, at least in this critical loop. Now most things are not critical. I told you that this is not critical, the BSP. This is not critical. It's only these that are critical. These are the most critical parts. And I've seen some you know, I am fixed mul and I am fixed dev. I am fixed dev is might be worse. In the BSP, maybe in phase 1, I think it was in phase 1. In some gameplay places, the movement of some enemies. But usually these are, they don't seem to eat the performance. So that could be insignificant, but it's an idea that because there are many of them, if we could replace the smul, if it existed, I need to make a test with some assembly code. Probably it doesn't. Probably just for half a generation we lost it. Because you could replace it, I mean, you still have to write a function with smul. I don't know if you could inline the assembly. It still would have to call a function, but the function will use this long multiplication to 64-bit and return the 32-bit result, and it would be quite fast. And you could, if you could write that, you could replace all the places around, and maybe overall it would get a bit performance, but maybe not. Maybe it would be minimal. So that was the idea. So, but if it's something easy, if it's just, but probably we missed this feature. Probably, I assume that if Becky knew it, she would have used it. But maybe, probably we are this and we don't have this M processor. See, we are, it's just the line of things that would be nice to have. Now, the alternative is to do the trick I did on phase 6 1, phase 6 2, where it mattered, that single I fix mul that it mattered. I could try to do similar tricks at other places. But that's a big problem because you don't know what happens. Maybe you change something in the BSP and you see, oh, it works. And then in some later level, some BSP traversal is not precise and you get things disappearing. And you don't know. You have to play through the whole. In a lot of places where this exists, it's not obvious. The testing is not obvious if you replace the IFM. Now, if you replace it, if you do those bit shift hacks, you don't know what you are going to break. Anyway, I was just thinking of the, I was looking on all that. That I found this recently and I was very interested. Those are very generic. I have some idea for the flow renderer, but it's very tedious and most probably it won't go. And even if it works, there's something on the vis plane, not the find plane, but the later the construction of the vis plane, the traversal. This is the one that might be a big task, so we'll see. I think the most important was. I think I might not have an optimal whole polygon renderer. I don't say about the whole segment. Generally, I should have a generic look at everything. Anyway, I was discussing that a lot. So now, maybe I redirect, I might finish that, but maybe I should, for the finale, I should. See, this bench. I should see if I can place the start bench period and the end bench period. What should I aim? I don't want to see the BSP anymore. I might. Just to test it, I might go for. I could do it for draw walls and draw planes. I could do it for starsec loop. I could do it for those three definitely. Now all of these are connected below. This is not always rendered. Is it? I think it's the sky. But it could be when I hit the fire sky and the other skies, I was doing it in a different way. Generally the sky, but we don't care. It doesn't. It's not the one that's hitting speed. These three are the cores, and they are subtrees of what they do. The starsec loop. We'll call this. I did cool. Maybe I can separate look. Seg loop sky, seg loop sprite clips, floor ceiling. I could check those functions. In a different benchmark. And the draw goals we call all of this. So maybe I could separately, instead of having everything together, maybe for today I will go to the phase 6. Oh, I don't have it. Start bench period. And go to. Is it one start seg loop? Right here, start bench period. Let's call it 1. Does it start from 0? Does it matter? Zero. I might have to make macros that will will say I might have to do it different. If def profile on starsec loop. Start bench. Segloop, start bench. Because if I keep those, but I might not keep them. I could put them, do my bench and remove them. See, I still have the wireframe mode, but I'm not using it. I have it somewhere. So I can literally so instead of putting everything, I could improve this thing with the... Now here I could have an increasing number, but you might want to have a start here and then here with an ID. I could say start bench period and would use a new index, and the end bench period will end this bench, the last current index. But what if you have a start 1 1 here and it encapsulates a smaller part that starts 2 2, and I could have a different visualizing if I have 3, if I have a bigger bench period that encapsulates a smaller, so that I can see you could split the bar in 2 pieces or something. Yeah, there is more stuff that could be done, but you have to visualize it. So you have the end walls, the draw walls, draw planes. The seg loop is that pre-step that is also important, as I say. 6-1. Does a lot of preparations per column, per whole segment, per column. Everything per column, there are a lot of overall columns in some views. Individual columns. And this one is drawing that stuff. And drawing the walls, and the 7 is drawing the floors and ceilings. I could separately show those later. Yeah, I have this idea. Now, there is a problem though. Does it compile first of all? Yeah, include bench. Let me do something else. Now, Doom is a big generic header file. Because I might be including and not including if I remove that code. Now I add another inclusion. It's not going to add. And also it has the profile, that's good. Define profile, if profile on, off. Yeah, I mean, this is the header files, it's a chain of header files. So it might be dirty. Was there a warning? Okay, we have to do something in the bench. I have not completely ported the thing. So what you might see, let's see what you will see. I can even load that one. I guess that's how I will do. I can see the performance on this one, then on the sub functions, but maybe separate, not having all those bars from all the place. Here goes nothing. Will it work? Oh, no. Ah, yeah, there it is. The bars are there. But what is not there is the... I'm going to prove that later. What's not there? The text. Because I have disabled commented out draw text. Because the way I did it would be to use the fonts on the main menu. Which means use the fonts I had to use those fonts. So when the game starts, I load these fonts, or I have them on the file, or I create the cells for these fonts. But when I press start to improve memory, all those fonts are cleared. I cannot use them anymore because you don't need them in the game. That's how I did it in this one. But on the bench, I had to hack that. I have to hack even the mod menu. Start writing the skill no code for the profiling functionality. That's on the bench. I don't unrelate the dialog, the font data from mod menu. And I expose the draw text and draw number. Mod menu. Is there any change on the mod menu? No more changed. So I did some changes that I don't have. I made a static array. I could have just alloced and not delete. Because later I remove the static to expose them. I free them. And why did I change this one to? Maybe I had some issue, some problem. I could have kept this one and just not free them. So I might... I could have some problem with things freezing later, sometimes with the 3DO. And I still have a static table of the data, so I'm not... I mean, those are very small, they're not... But, oh, a lot of things have changed now. CCB text cell. Wait, do I do an alloc anymore? Oh yeah, fonts BMP, fonts map. I could say if not def profile on, free them, else don't free them because we are going to use... What is it? Draw. We're going to use draw text and draw number later. So yes, I guess I have to do this kind of hack. Mod, we don't have a mod menu. Is it here? In mod menu. And not here. The original Doom on 3DO, and maybe that's also Carmack's code on the Jaguar and on the PC. It used to have a global header with a lot of global functions external, which, yeah, from modern programming standard, it would be scary, but I'm fine with it. So a lot of things, and these comments were I mimic this stuff. If I add something new, I'm putting, okay, those can be found in this file. I'm extending it from this file. But I think this extended because I see this in Apple2, Apple2GS, 3DOC, and IBM C κλπ. These are things used possibly from the Burger lib too, that works in a lot of, because that's not mine, it can be mine to say Apple2G. But I might have used this notation, like if I ever add some stuff here, some extra stuff I need to extend, I have to put it in the right place, and if it's from a new file like bench, but it isn't, but and the Doom X is mine. I decided my additional stuff from my own files will be here, so that I, instead of making the original Doom header bigger, let's use this one for mine. No, not bench, mod menu. In mod menu, see. I have these booleans for when I select stuff for other parts of the code to know what is selected. Start mod menu, and I will add 256. What did I copy? Yeah, I copied the wrong thing. No, it's here. So now the bench will have to include do mix, and I wonder if, I don't know if this is the good thing to do. Placed at the end to make some structs visible to the external function, like playerty. I call them playerty seems something from the original Doom, not something that is mine. But maybe here. Yeah, those functions are mine, but they get a struct that was from the original Doom. So I wanted to make them visible. So I already have a chain. I know it's. I try to follow the way the original code is and try to clean it at places. I had done massive cleaning of the menus to create an easier system to add my own menu option, but it's still a bit painful. I still have to see previous menu options to add new. It's still not very obvious, but might be better than before. So we are including Doom as now. This is Doom capital, but it's Doom. Yeah, normally it should be like that. Whatever. And here we have commanded draw text. Is there a draw number? Oh, we don't use draw number. Because we do it with draw text. This is the name of the bench results. And this is the percentage text. It is the number and the percentage sign. So I ended up, I guess initially I was doing draw number, but then I'm like, okay, I have to do an sprintf because I want to also add the percentage symbol. So maybe I don't need to expose both of them, but I'm thinking I will still expose this one because later we might draw a number just for the milliseconds passed instead of the percentage without any extra symbol. So I will do it with draw number, why not? So, let's see. Mode menu and the campaign. God, I just messed up something. Yeah, there goes. Yeah, just a clean. Should I run? Okay, I'm going to run Phoenix. I could check the overhead of the cell cycle of the cell at some point. And I think the cell could be very light. This in this game, it's the CPU that is killing it. I was thinking to make some toggle on the menu that will stop the CPU doing, not stop calculating new columns and draw the previous cell. Although we have a limited number of cells and we flush it, we replace it with new. So I would have to increase the number for such a benchmark. So what if you had all the individual cells completing the whole pixel? What if you have them in a big list and you did one draw cell? What if you only did, or I can time the draw cells actually, start and end. Yeah, actually, I can try that and find the relative percentage like we're doing. Yes. So you see, draw planes, and you see something that the planes is the ceiling, the floor. At this view, the ceiling is very low, so there are a lot of pixels. All of these pixels and all of these pixels and those, they are software renderer. Two-thirds of the screens are software renderer for the floor and the ceiling, and even this one. There is a lot of stuff and very few wall segment hiding. So you could even get the total area of the floor ceiling pixels against the wall pixels. And so and so that's why they take the most. And interesting, the draw walls don't take much, even if there are a lot of wall segments, but they are very few in numbers and small. The size doesn't matter. But this preprocessor step to prepare the wall segments and the viz planes takes more, which is interesting. Now if we move, let's see those views, how they play. It's interesting. Yeah, now that's the interesting one. Draw planes, draw walls. There are more visible walls. There are floor here and floor and here. And they take less. So now this has dropped. The draw walls has been bigger than the star. This take half and half. The draw walls, there are all this, the stair walls, for example, it's column, 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 column. A lot of columns. And then those columns on the walls. I wonder if you could do things like that. Okay, if you reduce it. Now the draw planes are very low because it's the flat shaded, obviously. And especially if you do bright, it's even less. Because when it's a single column, it does vertical column, vertical fillings instead of converting to horizontal filling, which is an extra step. What if you change the scale? Now, it's not that the planes got more, it's that analogically the percentage of the total compared to the other have dropped. Now it's raised because 1 by 2 still more it's vertically that is scale. Are these the same? This has to do also with the V-spline creation. So you can come. I have to print the actual number, the milliseconds or whatever, or microseconds, whatever, because these percentages are between each other, which takes more. So it's not. You can make it faster, and the analogies might be the same. Now, what about the render polygon? Now, render polygon. It want 27 draw walls. 31 draw walls. Star set loop 30. You can see, I have to do milliseconds to see the difference. Star set loop 31. It's about the same. It would improve the draw walls if you switch to poly a little bit, because of the stairs that they are drawn with a single quad instead of multiple columns. And you can rotate and see the numbers change. And okay, when you look far away here, yeah, you can easily deduct things. So I need to improve this performance benchmark to add different options, and also have a way. Unfortunately, here, if I want to take it in from, I do this, but it would come back. It's just a trigger to restart it. I can change that. I can put an on-off flip easily. Hold on. Put the full one. Yeah, obviously draw planes takes more, but the star set loop, it will calculate the V-spline. There are more V-splines in this view. Will take a significant. I see the draw goals surprisingly take less. Again, it's a big floor. So I see now the seg loop is usually, even if it doesn't seem so. What if you look at the wall, zero draw planes, because no floor ceiling is rendered in this view. But the star seg loop, the preparation, the star seg loop will find zero V-splines, but it will find all the. And again, those numbers are analogous. It doesn't tell you this view is much faster than this, but you can compare the improvement. You compare analogically which of the three functions are wasting the more time. So I really have to add the other mode that is not percentage, but it's, yeah, I think now I can change this from a flipper to an option with a profile of percentages, milliseconds, and so on. Maybe I can have another selection below that says sort or not sort the results. Things like that. Again, draw planes, yeah, the software rendering. But stars glue, it's the same. You can't avoid the software rendering. Now, I have the plane, the low quality assembly version. See, the floor becomes more low res. Draw planes 35, but that's a percentage. 41. So it does take less. And if you do it like that, now it's, and you see now it's fine. Neither the draw goals, not the draw. It's that loop that is a pre-process loop over the wall segments to get the information to draw the walls and the planes. I know now which part I have to look thoroughly. And it's easier when you have these three options. Previously, I would have all kinds of functions, and you would miss a bit what you really have to focus. But now I have isolated, and I can isolate the subparts in different benchmarks and get a better idea. Because we know that the software rendering for the floor and the ceiling is heavy, and we can't do much. But when it's off, I mean, even if it's heavy, you still have those taking. Imagine if that was much optimized. It will give something. And at least you could put this one, which is okay, and you should have much better frame rate than with this one. Let me say, this is a good case here. This case, those tear and this simple close view, this will go in front, but let's see. This is 13.4. The Polygon is really good on that. 15. It goes from 13.4 to 15. 15.6. It's a good increase for the Polygon. Because you have a very closed room. Very close together. And all these stairs that would be column, 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 column. From here to here it's 288 pixels. 288 column. And again, these are less. It could be 200, 180, 170. They accumulate to a lot of individual columns. And when you have the Doom, the original renderer, but when you have the polygons, this could be one quad render. Unless the bitmap, if the bitmap is here, it might be two quads. It's split, but it's way less elements to prepare. And also those close walls might be polygons. So this is a good case, but in most cases you don't see improvement with the polygon. So now we could even see it. No, okay, we are here. Let's see, draw walls. See, now the draw walls take more. The stars glue and the draw walls. 37, 20, 37, 28, 16. Polygon. 32, 20. The draw walls were 37. The draw walls were up, and that's a good improvement. See, there are various cases. What is it trying to do here? Yeah, this kind of loading, it makes the letters flicker. I haven't completely. If it's slower, it's because the profiler also runs and the extra drawings. By the way, although maybe it is that slow here. Okay, I need to. Did I press them? I need to get in a certain view. This is the slowest view. I just need to kill that. Okay. This view from here towards up there, because you have all these stairs, all those windows, the outside. Somewhere here is the slowest it can be. And this is a good. Again, the star seg loop dominates, the draw walls is higher, the draw planes is lower. "26 star seg loop draw walls 25 18." The poly doesn't do here because there's a lot. No, the draw walls went to 22. What do you want? And you need to see it with milliseconds. "22 25." But the overall, the amount of whole columns, the stairs, those windows, those walls there, a lot of, if you accumulate the number of individual columns, it goes very high. But even polygons doesn't save, because the far away walls, if you make tiny polygon, because this texture is repeated, so it has one quad polygon, one quad polygon. You cannot, there is no tile repeat on the texture on the 3DO. You have to, even the big walls, even this wall, you might see one surface. It's not one quad, one cell quad. It's one cell quad, two cell quads, three cell. It's subdivided, no matter what. When you look there, it's not just one big quad. It's subdivided and also vertically subdivided because this texture is the textures are repeated. So cell quads doesn't whole polygons, whole quads using the cell for the polygon mode doesn't save you because. And I realize when you are far away, the polygons are so small that they are basically identical to columns. So why not? And there was performance drop. It was worse. So my system, when you have polygons, those close ones might be polygons. Those from a distance, if they are very thin polygons, I switch to the columns. Those are columns and not polygons. So I switch between the two renderers. And I think I did that. I was putting the polygon mode in big areas, and the performance was way worse. And it's even worse if you account for cell engine and you have big textures far away repeating many times. That's an enormous read for them. And I think I did this system because I did realize that in big areas I was dropping frames instead of. In the same way, I was increasing frames with the state. I was dropping 2 frames from 10 frames to 8. important now. Now I found some heuristic to be almost the same, or maybe at some cases drop 0.1. And in the good cases to go from 0.1 up, 0.5 up to 1 and 2 at best. FPS from 10 to 12, from 13 to 15. I'm wondering if it changes. That's a heavy one. If I say ignore the cell. Draw planes are a bit faster. I mean 19 to 20. But it's minimal, it's the CPU. Here, you don't... Yes, yeah. No, not that. See, close enough, it's much better with poly. Draw walls. Because it's one quad that even fits here from several columns. But anyway, I wanted to see the other thing. 34, 30, it might be not, you have to do milliseconds or something. 34, 31. How does it say 33, 26? But true. Yeah, you can. I have to do the other one with the milliseconds. I have to do some more stuff. You can't easily say. The other thing I could do maybe. Uh, but it's not easy to do. Maybe in flash CCBs. That's the background, we don't care. Flash CCB array wall. Flash CCB array wall. Flash CCBs. Flash CCB array plane. I could... That's one way to see. How much performance the cell is really taking. I mean, quite minimal compared with CPU at this point. It's not the cell the killer. But bench. No, face. Flash CCB array wall. Flash CCB array plane. Draw CCB array plane. Draw cells. I should somehow accumulate it at the end. I mean, we care about phase 6 to phase PL. Yeah. I would like a common one. There could be a thing I could... Phase 6 to phase... Yeah. What does the bench do? when you do start, time start, and when you end, time ends. We can accumulate for the same index. It still puts the name, but yeah, no. But that's what. Okay. Get time difference. Time start the end. And time start you get okay. So I think even if it's in separate places, I can say I can accumulate the total. At every place we have draw cells, stance bench period. I will put another. Yeah, see, we have the. I could get an increasing number really. We have 0, 1, 2, isn't it? I will change this. This can be better. 0, 1, 2. You could have an increasing number. But what if you want to use a specific number? That's the thing. Maybe use the name. Use the string. Don't add. I just didn't want them to do a string search, string compare or something. But why not? So you can enclose here draw cells and bench period 3, and you can use the same with the same name as long as the index is the same. So because here it will accumulate start and end, but what about later? It's accumulate the sum, and every time you do start before it's, so you can have many different places in your code that you want to accumulate the total time differences. Find row cells here, flat polygon. Do wall segment flat poly. That should work. As the polygon, and this one CCBRE wall generally, and phase 7 is for the floor and ceiling, and we have the vertical is for the one. Now you have the sprites too, but the sprites are very minimal in those views. So all of this will accumulate, and at the end of the frame we will get the total of the times, even if it's different things different, and we will probably get something. Okay, run Phoenix, because we will see the total overhead of the cell accounting on. Surprising how it works. Okay, I can improve this bench thing, definitely. I can definitely improve it to give me better results. So I'm really curious. Hope it doesn't crash. Yeah. So, the draw cells. See, as I say, the time is spent drawing the cells. So the thing that the time that the cell hardware spends is 3% compared to the time the other things in the CPU are happening. So and now this is with sales accounting, the sales performance accounting. If we ignore the cell performance, it goes to 0%. Wow. But if we return and face a wall, no planes, it goes 9. Even in this case where not much is happening on the CPU, it's telling. Oh, that takes 4% because there are many more well columns, I guess, that are broken in individual linked list of cells. But the draw cell is just the call, the draw cell's call. It's after we prepare the columns, but there might be more. And also those are percentages of the overall. But generally speaking, you see that, okay, that you don't gain something. So we know what we have to optimize, obviously. Even if you look at the wall, you get a 9% speed. If the CPU is relaxed, in this view, the CPU is spending less time. And you don't see it because if you see the percentage, it seems the same, but it's I say that 10 times in this video. I have to print some milliseconds instead of averages. Yeah, but generally speaking, it's that. So the cell renderer is fine. There are not too many things and too heavy things rendered. Now I wonder with a polygon, how does you won't see it. When you use this, the cell engine is doing more. It's taking the back buffer and it's rendering it in a lower resolution. So it's but I haven't enclosed this start bench end bench at those places, and I haven't closed the polygon. So it's analogical though, because the draw also is doing less. It's not real. Again, the percentage might tell you, oh, is the cell polygon slower? Is this where you break the code? No, because when you do this, there is a lot of more work done to the CPU. So but you see how it relaxes the whole thing, especially the draw. It's quite smoother with the polygon here. Quite smoother than. So I have to. Interesting though. Huh? I haven't done it for the sky, which is another. And it tells me, which is cool, that the draw walls, which still does some work to prepare the whole columns and so on. some preprocessor work, but the previous preprocessor is the star seg loop. First prepass on the whole columns, on the whole segments, and loop through the whole columns. This is very critical. The draw planes is critical, but we know why. It's because of that. Because of the software render, which if we remove, and also this will change. Man, it is the star seg loop. And the speed of the draw planes is isolated in one thing, which is as tight as it can, but it could be improved. It's the pure software rendering, but even without that, I can see it now. In some cases, the draw holes is not bad. It is the star seg loop that takes the toll. Which is the preprocessor step over the whole segments. So the star seg, look at the draw holes are the two parts, 6_1 and 6_2 phase. The star seg loop is necessary for a lot of things, for the V-spline creation, for the sprite clips, which would make a sense that if you replace the V-spline logic and sort the sprites with the whole segments and render them back to front, maybe you can avoid a lot of stuff on the star seg loop. But even if I don't do that, I can focus on the optimizing the star seg loop. Maybe I can just put everything down and start looking at it again thoroughly, and maybe ideas will come. I am kinda confident. I'm not going to be in time for the December, be able to replace the whole engine, but I might be able to improve things here and there. And that's it, guys. That's it. See you later in another video where hopefully I will have some improvement to show. Bye.